In lesson 70, we'll be talking about some different kinds of radical equations. We're actually going to take this lesson over 2 different days as there's 2 different scenarios that we'll see when it comes to our different radical equations. Let's go ahead and begin our lesson today by actually looking at what is a radical equation so we know what we're going to be solving together. By definition, a radical equation is an equation that contains at least one radical, that's like a square root or a cube root, that's radicand, and the radicand is what's underneath the radical symbol. The radicand contains a variable. So the variable or the letter that we're going to be solving for in our question is underneath the square root symbol. It's underneath the cube root symbol. Just so you can see some examples here of what radical equations look like and what a radical equation does not look like. Both of these are examples of radical equations. The first one I gave with an example of a square root. Notice inside the square root is x plus 3. The variable is inside of the square root, and that's the qualification for it to be a radical equation. The second example that I gave is a cube root. Notice I have 2 different cube roots. Inside of both of them contain our variable. Now, they do not both have to contain a variable, but at least one of them, one of the roots, does have to contain your variable in your question. Here's 2 examples of ones that would not be considered radical equations. The first one, x minus square root 5 is equal to 8. Yes, there is some sort of root, some sort of radical, but on the inside is just a number, the number 5. The variable is on the outside of the radical symbol, and it is not what I want to have a radical equation. The same thing true with our the fourth root example. The x is not inside of the radical symbol, therefore it is not considered to be a radical equation. So we'll be focused on the first set of examples up there on the screen for how we're going to correctly solve these radical equations. Let me go ahead and give you the steps that we're going to follow, and then we'll work through some examples together. In order to solve radical equations, step number 1, isolate the radical symbol. Remember, what does it mean to isolate? It means to get it on the side all by itself. You can have as much stuff inside of the radical symbol, but there can't be stuff on the outside of the radical symbol. So if there is, go ahead and move that over first. Number 2, you're going to go ahead and remove the radical symbol. So what I wrote, it says to raise both sides of your equation to the power of the index of the radical. Okay, so what on earth does that mean? If I need to remove a square root, well, what power or what exponent would I want to use? A square or a 2. If I wanted to remove a cube root where the index is 3, then what exponent would I want to use? A cube or a 3. So whatever the index, remember the index is the little number inside of the check mark area of your radical symbol. Whatever the index is the same exponent that you want to use in your question. So at this point, you've removed the radical symbol, and now you can continue solving for the x or whatever variable that you have on the question. Remember, we can't move things over if they're inside of the radical symbol yet. We have to remove that first, then we can continue solving. Now, the last step is a very important step when it comes to these radical equations. We have to check our answers. If I don't check my answers, all of the work's going to look perfect, but there could be a possibility that the answer that I get is not actually an answer on the original equation. So do always make sure that you just mentally check your work or put it on your calculator to see that you have the same number on both sides of your equation. What that's called, if you have an answer that doesn't work, is called an extraneous solution. Kind of at the beginning of that word, you see the word extra. It's an extra solution to the equation. So it says it's a solution of the derived equation that is not a solution of the original equation. Okay, so what does that mean? As I was working through the solving process, isolating the square root, doing the power that I needed to remove the root, that's the derived equation, the one that I'm doing the work with. As I'm working through the problem and I get an answer, I always want to check based on the original problem. Well, the answer that I got is not actually working in the original problem, therefore it's called an extraneous solution in your question. Let's go ahead and work through a few examples together so you can see how to correctly use our 4 steps to solve a radical equation. So our first one, the square root of x minus 25 is equal to 2. So step number 1 says to isolate the radical symbol. Notice on the left side of this equation is only the radical symbol. The minus 25 is on the inside, so I cannot move that first. So I don't have to worry about step number 1. Step number 2 tells me to remove the radical symbol. Well, what kind of radical do I have here? It's a square root. So how do I remove a square root? I'm going to square. If I square on the left-hand side of the equation, then I also need to square on the right-hand side of our equation to keep the work balanced. On the left-hand side, the square and the square roots are opposite, so they cancel each other out, and I'm just left with the x minus 25. On the right-hand side, 2 squared gives us 4. Now I'm ready for step number 3. I can finish solving. To finish solving for x here, I need to cancel the minus 25, so I would add 25, and that gives us our possible answer that x is equal to 29. Again, before I say that that is my final answer, I need to check my work. By putting my 29 back into the equation, does that give me a true answer? So 29 in for the x. 29 minus 25 gives me 4. The square root of 4 is equal to 2. Therefore, I know I have the correct answer on this question. Let's work through 2 more square root questions, then we'll do 2 that have cube roots as well. So I have the square root of 3x minus 17 minus 2 is equal to 6. So step number 1 says to isolate the radical symbol. This time there is a number on the outside of the radical symbol, so I need to remove that first. To remove the minus 2, I'm going to add 2 to both sides of our equation. So now I have the square root of 3x minus 17 is equal to 8. Notice I did not put the 17 and the 2 together because the 17 is inside of the radical symbol and the 2 is not. They're not similar terms that I can combine. Now we're ready for step number 2 to remove the radical symbol. Once again, I have a square root, so to remove a square root, I'm going to square on both sides of our equation. The square and the square roots are opposites, so they cancel each other out, leaving us with the 3x minus 17, the radicand on the left-hand side. On the right-hand side, 8 squared gives us 64. Now I just have a basic algebra problem, and I'm ready for step number 3. I can continue solving for x. The first step in solving for x, I would add my 17 over, and that gave me 3x was equal to 81. And now I'll finish by dividing by 3, and I think the answer is x is equal to 27. Again, before I say that's my final answer, I need to check it. I need to put it back into the original equation to make sure that my work was correct. If I put 27 back in, 3 times 27 was 81. 81 minus 17 is 64. The square root of 64 is 8, and 8 minus 2 does give me 6, so I know that I have the correct answer for x on this question. All right, one more square root example. The square root of x and plus 5 is equal to 1. So number 1, isolate the radical symbol. I need to get rid of the plus 5, so I'm going to subtract 5, and I have the square root of x is equal to negative 4. Now, if I continued, I'm on to step number 2, where I would remove the radical symbol and I would square on both sides of the question. My problem would now say x equals 16. However, if I put 16 back into the question, the square root of 16 is 4, and 4 plus 5 is 9. But I need the equation to equal 1, not the number 9. So why is my answer not working? Why is this called one of those extraneous solutions in the question? Because there is no answer on this problem. If you remember, square roots are not equal to negative numbers. Anytime that I take the square root of something, we always give the positive answer. Like for example, if I asked you guys, what's the square root of 25? You should be able to tell me the correct answer is 5, because 5 times 5 is 25. If I said, what's the square root of 81? Well, the correct answer is 9, because 9 times 9 is 81. So square roots are always equal to positive numbers. So if you notice right here in your work, when you had the square root was equal to negative 4, square roots can't equal negative numbers, and you automatically know there's no answer. If you didn't recognize that and you continue to solve like we've done in the first 2 examples, that's why I have to check my answer, because putting 16 back in that question would not have worked on the original problem. Let's finish up today by looking at two examples that have our cube roots. So I have the cube root of 2x minus 26 minus 4 is equal to 0. So same solving process that we just did with our square roots. The first thing, isolate the radical symbol. So I'm going to get rid of the minus 4, I'm going to add 4. So I have the cube root of 2x minus 26 is equal to 4. Now here's just one slight difference I'm going to do. The first three examples were square roots, so we squared to remove the radical symbol. Well, this time in the question, I have a cube root. The index is 3. So what do I need to do to remove a cube root? What exponent do I need to use? It is a cube or an exponent of 3, the same one that I had for the index of the radical symbol. The cube and the cube root, just like squares and square roots, are opposites of each other, and they cancel each other out, leaving us with the radicand 2x minus 26. On the right-hand side, 4 to the third, so that's 4 times 4 times 4 gave me 64. Continuing to solve, and as I finish getting x by itself. So we're going to add 26, and that gives us 2x is equal to 90, and now divide by 2, so x is equal to 45. Don't forget, got to check my answer. So putting 45 back into the original question. 2 times 45 was 90. 90 minus 26 is 64. The cube root of 64. Remember, a cube root, you're thinking, what can I use 3 times to come up with a 64? Well, what do I use 3 times? It's the number 4. So 4 times 4 times 4 was 64. So the cube root of 64 was 4, and then 4 minus 4 is 0, and that's what our equation was supposed to be equal to. So we know we have the correct answer for x. Last example for today. Negative 3 cube root of x plus 13 is equal to negative 9. So number 1, isolate the radical symbol. I can't have that negative 3 in front of the radical, so what do I need to do to remove it? Well, a number right in front of something we know means multiplication. So how do I get rid of multiplication? I'm going to divide, so I'll divide both sides by negative 3. So now I have the cube root of x plus 13 is equal to 3 for negative 9 divided by negative 3. We're trying to remove the radical symbol. To remove a cube root, we're going to have to cube. When we cube both sides of our question, we have x plus 13 is equal to 27. So 3 times 3 times 3 on the right-hand side of the question. Finish getting x by itself, so subtract 13, and that gives me that x is equal to 14. Before I move on, we're going to check our answer. So 14 plus 13 is 27. The cube root of 27 is 3. And negative 3 times 3 is negative 9. So we know we have the correct answer in our question. Now, the questions that we're going to see tomorrow, there's going to be 2 roots on the question. All of the examples we've seen so far, there's 1 square root or there's 1 cube root. Tomorrow's question, there'll be 2 square roots or there'll be 2 cube roots, and we'll see the extra step that we'll have to take if that is the case in our question. So make sure that as you're working on your homework, you're working carefully. I did want to point out about today's homework assignment. Your answers for letters C as well as for letter D are going to give you fractions. So go ahead and leave them as fractions for me. Don't turn them into decimals. So again, that's on page 499. Your answers for letters C and D are going to be fractions.